Guys, welcome back to a new video. This video is on integration. It will talk about some basic area under the curve, and we will look at some equations to do with this and look at how to work these out. So here we have a graph. This graph here is showing this function. So this function here is displaying this curve. So x squared as a graph is actually a parabola or something like this, a shape looking like this, equal on both sides. So our part that we have looks something like this, although that's a very bad drawing. So, as we're only working with one side of this, we only keep this side here. So that's what we have in our drawing right here. So now we're going to just get rid of this quickly. Then I'm going to show the formula to work this out. Okay, so the formula to work out this area under the curve is this. Well, the formula for any area under the curve is this. So the integral from a to b of f of x, function of x, dx. So in this case, what is f of x? F of x is a function, and in this case, well, in most cases, f of x equals y. And as you can see here, y equals x squared. So f of x equals x squared. Now, we need to know the a and b of this, because we can't really work it out if we don't know. We can call a here 2, let's say, and b 4. So now we know our a and b and f of x, we can solve. Okay, so we start up by drawing the formula again, but this time substituting in our values, and then f of x being x squared dx. Great. So now we basically find the antiderivative of an equation. So we want to find the antiderivative of this, because the equation given for the slope of it is x squared. So we want to find the antiderivative of x squared. The formula for an antiderivative is So I was thinking of the derivative. So basically, to get an antiderivative for the slope, we can just do this. So if it's x squared, we do plus 1 and then divide it by that. So the actual formula is x n plus 1 over n plus 1. So this is the formula here. So we're going to use this to solve. So we'll go ahead and clean up this mess. Great. So now we have this here. We will use this to solve. So that means it's x cubed over 3. Okay. Let's clean this up. Now, we have to plug in 4 and 2. So this equals 4, because we're substituting it in for x, cubed over 3 minus, just move down, so 4 cubed over 3 minus, so this minus here is essentially a minus 1, and the next thing we're plugging in is 2 cubed over 3. Okay, so this will basically give us our answer for the area under the curve, which is this here. It will give us the area of this shaded region here. So, if we put this into our calculators, we will get 64 over 3 minus 8 over 3. Got it? Perfect. So, now we just have to, as both of these equations here can't be divided by 3, we're going to just minus them from each other as they have the same denominator. So in this equation, we just have to minus 8 from 64, which is just 56 over 3. If we plug this into our calculators, we are going to get 18.6 reoccurring. So we can record it as this. Reoccurring. So that means that the area equals 18.6 reoccurring. Perfect. Now on to our next question. Okay. So, on this page, we are going to have the equation, if my pen wants to work, there we go. We can have y equals y equals x. So, if y equals x, we are going to have a straight diagonal line on 45 degrees. So something like this. Like that. Remember? Okay. So, this is actually easier to work out as we have geometry and it's not a slope. So we can just find the area of the triangle, which is a lot easier than having to work out the integral and then the functions. So here we are going to find, I'll show you two ways actually. I'll show you a way to do it geometrically and a way to do it using the area, finding it with an integral and the formula integral from a to b function of x dx. So we're going to plug in the values. We'll say a equals 0 and the other b can equal 8. So these are going to be our values to work with. So we'll draw our line here, and this here will be the area we're trying to work out. Perfect. So, if x equals y, then when x is 8, y must equal 8, because x equals y. So let's say 8, that's the new x, equals y, then y equals 8. See? So that means that, and remember, the formula for the area of a triangle is 1 over 2 base times height. So, the base of the triangle is going, I'll draw like a little thing here. So the base will be 8, as that is the distance between 0 and 8. And the height must also be 8, as x equals y. So, that gives our triangle. So, here, we can just multiply and then multiply it by half. So, 8 times 8 equals 64. So, 64 by a half equals 32. So, that must mean that the area equals 32. Perfect. Easy. Now we are going to do it with an integral. So, we come over here, and the formula is integral a to b f of x dx. So, now we plug in b, which is 8, and a, which is 0. So that becomes, and then f of x is y, and y equals x. So f of x equals x. So 8 to 0, and this is, and then x dx. Perfect. So now we find the antiderivative again. So the antiderivative of x is the x n plus 1 over n plus 1. So if we use this, x is x to the power of 1 here. You see this? X to the power of 1. So we turn this equation, so we have to plus 1 divided by 1 plus 1. So that becomes x squared over 2. So here we are going to plug in the values 8 and 0. That is a horrible looking 8, my fault, sorry. So it looks something like this. We plug the 8 in, so 8 squared over 2 minus 1, remember, over 0, minus 0, sorry. So it's 0 because 0 times anything is 0. 0 to the power of anything is 0, because it's basically 0 times 0. And 0 divided by anything equals 0. So therefore, this equation must equal 8 squared over 2. So 8 squared over 2 equals 64 over 2, which equals 32. So the area equals 32. See? And this was our old question. Area equals 32. There. So this is how we can work out the area with both geometry and the formula. This is our last example. It is going to be, we'll draw up a graph real quick. Line, line. Don't forget our triangles. Great. So now we are going to say y equals, let's say x squared. Oh, that is a weird looking x squared, I'm sorry. X squared that is horrible. X squared, let's say, I don't know, plus, I think, let's say, plus 1. Okay, say y equals x squared plus 1. Okay, so this gives us our formula. This gives us our y, which we will then use to solve. So first we need to draw a graph of what x squared plus 1 actually looks like. X squared plus 1 is x squared, the parabola, plus 1. So we take the parabola here, and then we have to move it up by 1 as we're plussing 1. So here on 1, we are going to add our parabola curve. There we go. That's our curve. So this will be at 1 as it's on x squared plus 1. So we'll plug in the values. We'll turn our a value into 4, let's say. 4. And we'll put our b value to 6, how about? So we want to find the area here. This is the area we want to find. So the way we work this out is we can't use geometry because this is an x squared function, not a y equals x. So it's not a straight line, it's actually curved like the parabola shown here. So we're going to have to use an integral. So remember our this 6, 4, and then we have to we need to find f of x being y. So f of x equals x squared plus 1. So x squared plus 1 dx. Great. Now, here we need to get the antiderivative of x squared plus 1. X squared is x cubed over 3, because, you know, x to the power of n plus 1 over n plus 1, and then plus 1x. The reason it is 1x is because to get 1, you need to have 1x to the power of 0, okay? But this x to the power of 0 isn't shown. But it's done like this as we need an x value, and x to the power of 0 equals 1, because anything to the power of 0 equals 1. So 1 times 1 is just 1. So that's why this as a value, actual value, not a variable, is 1x to the power of 0. So knowing this, it is 1x 0 plus 1 over 0 plus 1, which is just x 1, so it's just x over 1, and anything divided by 1 is just itself. So we can take out this, as we don't need this stuff, and we'll change this to just x. So now we plug in, so now we're going to plug in our a and b, which are 4 and 6. So okay, now x cubed over 3 will become 6 cubed over 3 plus 6, as 6 is our x value in this. This, don't forget that this negative sign is -1, and then we have to plug this same formula in for 4. 4 cubed over 3 plus 4. There. So now we have to solve for that. And 6 cubed is 216 over 3. And then we just have to plus 6. Minus 64 over 3. And then remember, it's -1, and 4, positive 4, times by -1 equals -4. So -4, -4. So now we can put the equation together. So 216 over 3 plus 6 minus 64 over 3 minus 4. Here we can do the like terms. So this is like this, and this here is like this. So we can do 216 divided by 3 minus 64 over 3. As they have the same denominator, this is just going to equal 152. Over 3. Perfect. Now we can do positive 6 minus 4. So this is 2. So 152 over 3 plus 2. Okay. So now we're going to actually turn this into a fraction. And so we can get the same sort of fraction and add them together, we are going to times it by 3. So this gives us a common denominator being 3. And so we can just add the top fractions like normal, the numerators. So this is 158 over 3. Now, if you divide 158 by 3, we actually get 52. So bad. 52.6 reoccurring. So this gives us our area here. Area equals 52.6. Repeating. Okay, so that's it for today, guys. Thank you for watching. Key points from this lesson are: remember that the formula for finding the curve here, like that, is the integral, the definite integral from a to b. This is called a definite integral, by the way, because it's got two set values. And then f of x dx. So